All right, folks, beginning a new chapter this week and talking about something that is going to be pretty important, both in Algebra 2 and in the math classes that you all will take after Algebra 2, for those of you planning on going on. So you have just watched a video about functions, and I wanted to show you some examples of what you're going to do in today's assignment, as well as kind of touch base and make sure that you picked up on the important facts from that video. So you saw in the video a function described as something that makes a connection or that relates the members of one set to the members of another set. Now, for algebra purposes, what's going to happen is a function is going to take x values and it is going to connect those x values to y values. So I want you all to understand from the video that you just watched that this is a function's job. It is its purpose. Its purpose is to take an x value and then connect it or relate it to a y value. So that is a function's sole reason for being, is to make connections between x's and y values. Now, you saw x's described in a couple of other ways. This set of x values is your set of input values, so we're going to refer to x as being an input value. And you also saw the set of those x's being referred to as the domain of the function. So I hope you picked up on that vocabulary, that x, input, and domain all refer to the same thing. And likewise, you saw y referred to in other ways in this video. Y is referred to as an output, and y is also referred to as a range. Now, he didn't mention this in the video, but a little more terminology that we could introduce here. X would be called the independent variable. It's the one you have some control over. But then the function takes that x value and connects it to a certain y value. So that makes y the dependent variable. So there is a little extra vocabulary that we could throw in that wasn't mentioned in the video. So one of the big takeaways that I want you to have from this video is that a function's job is to relate or connect two things. And in algebra, that connection, that relation needs to be made between an x value and a y value. The function will take the x that you input and relate it to or connect it to a y value that it outputs. So that's the way these things are going to operate. Now, one of the things that he also talked about in this video that is pretty important that I want to make sure you understand is limitations on a function. That limitation that he talked about is one of the most important things. Okay? What he said in that video is that what you don't want is one to many connections. So when you're talking about functions, put the word no here. When you're talking about functions, you want no one-to-many connections. So to kind of draw you a diagram for this, if I am dealing with a function, what I don't want to have happen is when I input one x value, into that function, I don't want to have a situation where I get many different outputs, many different y values. if that happens, that I put in one single x value, one particular x value, and the function connects it to a whole bunch of different y values, then that's not a function. A function cannot do that. It can't take one particular x value and connect it to many different y values. So when I'm dealing with a function, what I want is this. So when I'm dealing with a function, what I want is this. When I give it one particular x value, I want it to connect or output exactly one y value. So you don't want one-to-many connections. You don't want one particular x value, to connect with many different y values. What you want is one x value to connect with exactly one y value. Exactly one, and no more than that. So each particular x value should connect with exactly one y value, not two or more different y values. So that's what we want in a function. So that was something else he talked about that was pretty important. So here's what you're going to be doing today. You are going to be given some x's and y's that have been connected to one another. And it's going to be up to you to decide if the way those x's and y's have connected represents a function or not. So that's the question we're going to be answering on each of these, function or not. So let's take a look at this first set of connections. And you'll notice that the connections here are written as ordered pairs, where an x and a y have been written together inside of parentheses. So when I go through here and I look at these ordered pairs, -2 for an x has been connected with 6 for a y. So -2 as an x has connected with 6 as a y. 2 as an x has connected with 0 as a y. 3 as an x has connected with 6 as a y. 4 as an x has connected with -1 as a y. And then finally, 5 as an x has compared with 3 as a y. So my x values are -2, +2, 3, 4, and 5. So -2, +2, 3, 4, and 5. -2 has connected with 6, 2 has connected with 0, 3 has connected with 6, 4 has connected with -1, and 5 has connected with 3. So what I want you to notice is that each of these particular x values that I have over here has connected with exactly one y value. -2 connects with 6, and that's all he connects with. 2 connects with 0, and that's all he connects with. 3 connects with 6, and that's all he connects with. 4 connects with -1, and that's all he connects with. And then 5 is connected to 3. So what I have is 1-to-1 connection, and that's what I want. So this particular example is a function. These connections would represent a function because I don't have any one-to-manys. Each particular x is connecting with exactly one y value and only one y value. So that makes this a function. All right, here's another one. Let's take a look at what we've got here. Look at x values. We've got -3 as an x value that has been connected to 2 as his y value. -2 as an x value has connected with 2 as his y value. 1 as an x value has connected with 2 as a y value. -3 as an x value has connected with 1 as a y value. And then finally 0 as an x value has connected with 3 as a y value. So here's what I've got going on. My x values are -3, -2, 1, and then you'll notice here's another -3. That's repeated. So I'm not going to write it again. I've already got a -3 up here, so I'm just going to go ahead and go with that. And then 0. So when I look, I've got 1, 2, 3, 4, 5 XY connections, 5 ordered pairs, but only 4 different x values. Negative 3 is repeated here. So I want you to notice that negative 3 is connecting to 2 as a y value, and then negative 3 is also connecting to 1 as a y value. So negative 3, that one particular x value, is making two different connections to y values. Negative 2 as an x value is only connecting with 2 as a y. 1 is only connecting with 2 as a y, and 0 is only connecting with 3 as a y. So these three x values are behaving the way they should. Each of those particular x values is only connecting with one and exactly one y value. But this negative 3 up here is causing us an issue because he is making one of those one-to-many connections. One x connecting with many y's. So because of this one is not a function. Not a function. Because we have one x that is trying to make connections with many different y values. He should only make connection with one and exactly one y value. So that's the difference. You want each of the x's in your ordered pairs to connect with one and only one y value. It can't connect with two different y values like that negative 3 is. All right, here is a table. Here is a table to look at. I have an x of negative 2 connecting with negative 3 as a y. I have negative 1 as an x connecting with 0 as a y. I have 5 as an x connecting with 5 as a y. 4 connecting with 3. And negative 1 connecting with 7. So again here, if I start looking at this, my x's are negative 2, negative 1, 5, 4, and then all at once I get down here and I repeat an x value. So I have a negative 1 being repeated. I'm not going to write it again. He's already there. So negative 2 connected with negative 3, negative 1 connected with 0 the first time, and then connected with 7 the second time. 5 connected with 5, 4 connected with 3. So this x value is okay. Negative 2 as an x only connected with exactly one y value, which was negative 3. This one is okay. An x value of 5 connected with one y value, which was 5. And then 4 is okay. 4 connected with 3, one x value connected with exactly one y value. Here is where we are in trouble because you have a one-to-many connection happening. Negative 1 is trying to connect to two different y values. So because of this situation right here, this one would also not be a function. Now let me just say real quickly, I'm writing all of this out over here every single time because I am, again, in a situation where I am teaching this in an empty room where you can't ask me questions right away and clarify things right away. So you don't have to write all of this stuff out that I'm writing. My purpose in doing that is to make sure that I am as clear as I can be about what's going on here. So kind of keep that in mind. I'm writing a lot of stuff down. A lot of it you will not have to do. But when you're looking at something and trying to determine if it's function, remember that limitation. You don't want a one-to-many connection to be happening. You don't want one x value, one particular x value, like negative 1, trying to make many different connections with y values. So that one x value trying to connect to two or more different y values. That's what you don't want, is one particular x value trying to make connections with more than one different y value. All right, now, you'll notice this time, this one is written in a way that's a little bit strange. Right here, this, by the way, is called a mapping diagram. This bubble over here is your x's. So your domain, your input set, would be 6, 7, and 8. And then you'll notice over here you have your y values. So your range or your output set would be negative 4, 3, 1, and 5. And so notice how this thing shows you the connections. It shows you the connections with the arrows. So you have an x value of 6 that is connecting to a 3 and also connecting to a 5. Your x value of 7 only connects with one y value, and that's negative 4. And your particular x value of 8 only connects with one y value, which is 1. So what I'm looking for here is, do I have any one-to-many connections? Do I have any situations where I have one particular x value that's trying to connect up with many different y values? And the answer is yes, I have that right here. My particular x value 6 is trying to connect up with two different y values, which are 3 and 5. So this would create that situation again where I have something that is not a function. I want each of these x's to connect to exactly one of these numbers over here. Each x connects to exactly one of these numbers over here. And if it tries to connect to more than one of those numbers, if each one of these, any one of these, I should say, any one of these tries to connect with more than one number over here, that's when I'm in trouble. That's when I'm not dealing with a function. So you don't want one-to-many connections. Now, on this next part, you'll notice that I have a graph. And in the video, he talked to you about the vertical line test, which I'm sure you will remember from Algebra 1. And what the vertical line test did is it gave you a way to see if a graph was a function or not. And so what we do here is we take our vertical line and we put it on the graph. And what we're interested in is how many times that vertical line comes in contact with the graph. So here's what you're looking for. Where does this vertical line intersect this graph? Where does it come in contact? And when we look, we see that this particular vertical line intersects this point right here on the graph. And that's the only point that it touches. The x value for that point would be negative 1, negative 2, negative 3, negative 4. And the y value would be 1, 2. So on this graph, negative 4 relates or connects to 2. All right? I'm going to grab my vertical line and I'm going to drag it over a little further. Well, shoot, I dragged the graph instead of the line. All right, so I'm going to drag my line on over a bit. And again, I want to look at the point on the graph that vertical line touches. So this time I see my vertical line is touching this point of the graph. That's where it comes in contact. And that's the only point it touches. That would be negative 1, negative 2 for x. And then that would be 0 for y, because that's on the x-axis. So notice on this graph that negative 2 connects to 0. All right, so now we'll grab our line again, drag it on over. Okay, this time when I look at that line, it is touching that point on the graph. And that's the only point it touches. So the x for that would be 0. And looks like the y would be negative 2. So this graph connects 0 to negative 2. This function, or potential function. Drag this on over. Well, I'm having trouble here. Hang in there till I get it. All right. Drag the vertical line over a bit more. Again, I'm coming in contact with one point here, which is this one right here. And that looks like that would be 2, 0. So an x of 2 is connected to a 0 for y. And then one last move here. move that line one more time, and what I see is that I am coming in contact with one point on that graph, and that would be 1, 2, 3, 4 as an X, and then 1, 2 as a Y. So 4 is connected to 2. So look at your ordered pairs here. Do you have any one-to-many connections being made? Your X value of -4 only connects with 2 as a Y, so that's good. Your -2 as an X only made one connection, and that was with 0 as a Y. Your 0 as X made one connection, and that was with -2 as a Y. Your 2 as X only made one connection, and that was 0 as a Y. And your 4 as an X made one connection, and that was with 2 as a Y. So this graph passes the vertical line test because each time I placed the vertical line on that graph, and I paid attention to the point where the graph and that vertical line met there was only one. So this graph would be the graph of a function. So what you're looking for is when you place the vertical line on the graph, at how many different points does it contact the graph? Does it touch the graph? Does it cross the graph? If it's more than one point, then that means you have that one-to-many situation going on, and it's not a function. All right, so let's look at this one. Let's look at this one. If I grab my vertical line and maybe. If I grab my vertical line and I drag him over here to my graph, let's put him right here. Here is the graph. It's this sideways U shape, this curve. And what I want you looking at is how many times does that vertical line cross that curve. And what you can see is that it's actually crossing twice. Once right there, and then once right there. So if I were to look at the ordered pair for this point, that ordered pair would be -1, -2 for X, and then 1 for Y. So that's -2, 1, -2 connects to 1. And if I do the ordered pair for this point, it's -1, -2 for X, and then -1 for Y. So notice what I have here. I have that one particular X value of -2 that is trying to connect with +1 and trying to connect with -1. I have a one-to-many connection being made, and that is what I don't want. So this one is not a function. So here's how vertical line test works. If your vertical line contacts the curve at more than one point, if it intersects 2 points at the same time, then that makes it not a function, because that means you have a one-to-many connection going on. All right, for this particular graph, I'm going to go a little quicker on this one. All right, if I grab my vertical line over here, well, that's easier said than done, isn't it? And grab it over here. All right, this is my graph right here, this ray. You'll notice here, the vertical line intersects one point on the ray. That's the only point it's touching. If I scoot it over a little bit, my vertical line is intersecting the ray right there, and that's the only place. If I scoot it over even more, my vertical line and the ray are intersecting at a single point. And you'll notice if I slide this across, at every single place, this vertical line and this ray only have one point in common. They are only touching at one spot. So this would be a function. That would be a function. So touching one time is good, more than once is bad, because that means you have those one-to-many connections trying to happen. Now on this particular graph, I want you to notice that it starts out going uphill, and then it has this section right here where it's straight up and down, and then it starts to go uphill again. So if I grab my vertical line, so I can use the vertical line test, and I drag him over. If I sit him down right here, I'm passing the vertical line test because this vertical line crosses the graph right here. And that's only one place, so I'm good to go. Again, if I were to scoot it over here, when I look at where this vertical line crosses the graph, it crosses right here. Again, that's only one point. I'm good to go there. But if I move my vertical line to this section, you'll notice that my vertical line and my graph are in contact all the way through that section. So that's a lot of points of intersection. They are in contact all the way through there. So this would actually fail the vertical line test and would not be a function. So, with functions, here's what we need to know. A function's job is to take an x, which is a member of the input set or the domain, and to relate it or connect it to a y, which is a member of the output set or the range. That's how they work. They connect x's to y's. In a function, the limitation is that you can't have one-to-many connections. One x, one particular x, that is trying to connect with many different y's. Each particular x value should connect to exactly one y value, and no more than that. So not one to many. You want one particular x to connect to exactly one y. With graphs, vertical line test will tell you if you're dealing with a function or not. Put a vertical line on the graph. Look in particular at the point where the graph and the vertical line come in contact with each other. If there is only one point, then you're good, because you have one particular x pairing with one particular y in that point. What you're on the lookout for is situations where you have one vertical line that is intersecting a graph in two different places at the same time, because that means you have those one-to-many connections going on. One x value that's trying to connect to many different y values. You did this in Algebra 1, so you have some experience with it, but definitely if you have questions, contact me, because this is super important. For this year, because we are going to deal with functions a lot, and then for those of you who want to take trig or pre-calculus or calculus, functions are going to be a big part of your study. So any questions, be sure and contact me. So that's it for today. Tomorrow we'll take this one step further. Y'all have a good day.